Okay, so it says find all zeros of this function, this ugly third degree polynomial. And so if you watch the video attached to this question, they start by listing out all the possible zeros, and that's just a waste of time because usually there's going to be a significant number of the possible zeros. So the first thing you're going to want to do is just take this function and graph it. So I've put the function into my y equals. And then just to get a standard window, I'm going to hit zoom 6 to get the 10 by 10 window, or 20 by 20 window, I guess you could say. And this will give me the real roots, and I can use the real roots to help solve for the imaginary roots or complex roots. So I need to figure out what that x-intercept is. That x-intercept is my real root. So to do that, I'm going to hit second trace to go to the calculate menu. I'm looking for a 0, so I'm going to hit 2. And I just want to put the cursor anywhere to the left. It says left bound. Put it anywhere to the left of that 0. So right there is good. It's to the left on my graph. I'll hit enter. Right bound. I'll move it to the right, hit enter again, and then it'll ask you to guess. Just hit enter one more time. So it looks like that value is -2, 0. So when x is -2, I get 0 out of the function. So if -2 gives me 0 out, that must mean if I factored this thing, that x plus 2 would be a factor. X plus 2 times something. Imagine I plug -2 in, you'll get 0 out. So whatever the value is at the x-intercept, you can just change it and give me the opposite inside the parentheses, and that's going to be your factor. So I know x plus 2 is a factor of this. So now what I can do is I can divide this thing by x plus 2 to get whatever's left over. So I'm just going to use polynomial division. I'm going to rewrite this thing, 9x to the third plus 30x squared plus 30x plus 12. And I'm going to divide that by x plus 2. First thing I'll do is say x times what gives me 9x cubed. That's going to be 9x squared. Then I will multiply 9x cubed. 2 times 9x squared is 18x squared. I'm going to subtract those. Those are going to cross out. 30 minus 18, I get 12x squared. X times what gives me 12x squared? Well, that's going to be 12x. So I get multiplying, I get 12x squared. 2 times 12x, I get 24x. Subtract again. Make sure you put, I really should put these in parentheses or brackets. It's my fault. I get 12x squared minus 12x squared. They go away. I get 30x minus 24x. I get 6x. Bring down the 12. X times what gives me 6x? That's going to give me 6. So I get 6x plus 12. And everything goes away because this is a factor. So that there shouldn't be any remainder. So this function is the same as x plus 2 times 9x squared plus 12x plus 6. Well, now this is a quadratic, so I can find the solutions that make this thing 0 by using the quadratic formula. As soon as you get down to a quadratic, you're good to go. So I'm going to ignore this for right now, and I'm just going to figure out when this thing equals 0. So I can pull a 3 out. They're all divisible by 3, every term here. So I'll put the 3 in front of everything. So I'll leave that x plus 2 there. And then I'm left with 3x squared plus 4x plus 2. I want to know the values that make this thing 0, so I'm just going to plug in the quadratic formula. So I get x equals -b, -4, plus or minus the square root of b squared, which is 4. 16 minus 4 times 3 times 2, that's 4 times 6. all over 2 times 3, which is 6. So I get negative 4 plus or minus the square root of 16 minus 24, which is negative 8 over 6. This is negative 4 plus or minus. This is going to be 2I root 2 for 6 once you simplify the negative root 8. And then you'll see here that the 2, the 6, and the 4 are all divisible by 2. So I can factor out that 2, and I'm left with negative 2 plus or minus I root 2 over 6. So those are my other two zeros. So I would do negative 2 plus I root 2 over 6 and negative 2 minus I root 2 over 6. Okay, it's messy, but that's your answer. This next one's going to be done similarly, but we're going to have to divide twice. And you'll see in a second once I graph this thing. I'm going to go back to y equals, clear out what I had. This is going to be 9x to the 4th minus 9x to the 3rd minus 186x squared plus 372x minus 240. Standard zoom again. So we don't really care what's happening off screen. I just care about the x-intercepts that are on the screen. So I'm going to hit second, calculate my zeros. You should be able to tell just by looking at them. But this looks to be about, negative 1, 2, 3, 4, 5. So I'm just going to keep pushing left until I'm really close to negative 5. Can't even see the cursor. But if I hit left bound to the left of negative 5, right bound to the right, it gives me the first one. This is saying negative 4 times 10 to the negative 10. That's basically just, whenever you see that, that just means 0. So this point is negative 5, 0. For these types of problems, you should just be able to tell really by looking at the graph where they're not going to give you decimal x-intercepts. And you can do it again here, but this is going to be 1, 2, 3, 4. This looks like positive 4, 0. So if these are my x-intercepts, that must mean that x plus 5 is a factor and x minus 4 is a factor. These are my factors. Okay, these are my zeros. So now I just need to figure out what's left once I factor these terms out of the polynomial. So let's do x plus 5 first. Okay, going through, I would do 9x to the 3rd, so I get 9x to the 4th, plus 45x to the 3rd, subtract, negative 9 minus 45, that's negative 54, x to the 3rd. So this would be minus, and you can bring this down. Maybe I should be doing this. It's actually better practice, 186x squared. X times what gives me negative 54x to the 3rd? That's negative 54x squared. So I get negative 54x to the 3rd minus negative 54 times 5. That's 270 x squared. Subtract again. So these cross out. Negative 186 plus 270. That is, I don't want to mess that up. Negative 186 plus 270 is 84. This is 84 x squared. Bring this down. That's plus 372x. So x times what gives me 84x squared? That's going to be 84x. Moving right along, we get 84x squared plus 84 times 5. That's 420x. Subtract again. They cross out. 372 minus 420. 372 minus 420. Negative 48x. Bring down this last guy. Negative 240. X times what gives me negative 48x? It's negative 48. And so I get negative 48x. 5 times negative 48 is negative 240. Oh, that's wonderful. So we have no remainder. So I can divide this polynomial by this factor. So this thing becomes x plus 5 times 9x to the third minus 54x squared plus 84x minus 48. And then you would just take this part here, the quotient, and divide it by this factor now. Ignore this guy. That's just going to mean one of our zeros is x equals negative 5. One of our zeros is going to be x equals 4. Now, to get this factor even further, factor out an x minus 4 using the polynomial division technique. Once you do that, you will have x plus 5 times x minus 4 times your quotient from dividing out the x minus 4, which will be a quadratic. This will be some quadratic. So you can use the quadratic formula to find the non-real zeros of whatever's left in here.